Hey guys, in this video we are going to be looking at the binary search algorithm, which is an efficient algorithm for finding a specific value in a sorted array. So I'm going to explain how this works, and we are going to look at an implementation of it in JavaScript. So if you are coming from another language such as Java, Python or C++, you can still stick with me because I'm going to be explaining the concept of how the binary search algorithm works, so you don't have to really worry about the language. So let's get into some code and let's see how this works. Okay, so binary search is an efficient algorithm for finding a specific value in a sorted array. Remember, the array has to be a sorted array. It works by repeatedly dividing the search interval in half. If the value to be searched is equal to the middle element of the array, the search is successful. If the value is less than the middle element, the search continues in the lower half of the array. If it is greater, the search continues in the upper half. So I'm going to use the target value or our search value 5 and this array to explain how this works. So basically what we do is to find the midpoint in this array. So we are going to take 9 as our midpoint, which is actually the midpoint, and compare it to our search target. So if this was 9, then we are done with our search because we have found our search value. But then this is 5. So the next thing to do is to check if 5 is lesser than the midpoint or greater than the midpoint. So if it is lesser, then you concentrate on the lower half of this array. If it is greater, then you concentrate on the upper half of this array, right? So you keep doing that until you find the search item. So in this case, we have 5, which is lesser than 9. So we are going to focus on the lesser half of the array. So you basically repeat the process until you find your search item. So let me write some code so that we can understand this better. So I'm going to go on to write our function, which is binary search, which takes the array and the target. Okay, so the first thing to do is to retrieve the first index in your array and the last index in your array, because you want to use these values to calculate the midpoint of your array. So I'm going to say let left be equal to 0, which is the first index, and say let right be equal to the length of the array minus 1. So we do this to get the last element in the array. Okay, so the next thing to do is to write a loop, and the loop is to basically continuously get the midpoint and compare that to our search target to determine if it is equal to, greater than, or lesser than our search target. So I'm going to say while left is less than or equal to right, we have our code over here. And the reason why we have this condition is to basically keep the loop running whenever left is lesser than or equal to the right index, right? So we stop the loop when the left value passes the right index, when the left index passes the right index, sorry. So the next thing to do is to find the midpoint. Let me write find the midpoint index, right? So we are going to do this by saying let mid be equal to the left plus the right index, all divided by 2, because we want half of that. But then we have to surround this with math.floor so that we get a whole number. Okay, so the next part is to basically, let me write this comment, check if the middle element is the target, right? So you check if the middle element is the target. So you say if array mid, we are taking the value in the middle, we are comparing that to target. If it's equal to the target, then you basically just return the mid value, that is the mid index, right? So we have found our value and we have returned the index. But then if it is not equal to the target, we have to write another condition and say else if target is greater than the value in the midpoint, then we want to update the value of our left. So we are saying the left is going to be mid plus 1. So let me scroll up and let me show you what this is doing. So we are saying that if the target is greater, so if this target is greater than the midpoint, we want to update the value of the left variable. So the left variable was initially here, right? So we are saying the left is going to be equal to then mid plus 1. That means it's going to start from here. This was our midpoint, so we are saying mid plus 1. So we are going to start from this index, right, to the last index, which is our right index, right? So we are going to be focusing on this interval. This is what this means, right? Else we do the opposite of that and say right is equal to mid minus 1. Yeah, so we do the opposite and say right is equal to mid minus 1. So what we are basically doing is, if the target is less than the midpoint value, we are going to be focusing on this range. So our midpoint, our right value is going to start from here, and our left value is going to be here. Okay, so if we do this and we haven't found what we are looking for, or the element we are looking for, we can just return -1. Okay, so let's test this to see if this works well. I'm going to say const sorted array and pick the array that we have at the top. Okay, and we are going to say const target value is going to be equal to 5. So I'm going to say const result is going to be equal to binary search. We pass in the sorted array and we pass in the target value. Okay, so the moment of truth, let's see if this works. So I'm going to print out this to the console result, open up my console, and let's run this to see if it works well. So I'm going to say node binary search. Okay, so we have it over there. We have 2, so we have it correct because 5 is at the second index. So we have 0, 1, 2. So we have found 5 at the second index. So if I should change this to, let's say, 20 and run this, then we are going to have the 8th index. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 20 is at the 8th index. If I should change this to 2, then we are going to have 0 because 2 can be found at the first index, and that is index 0. So that is how to write your binary search algorithm. I'm going to push this code to my GitHub repo and leave the link in the description so you can check it out for yourself. Okay, so the next important thing to talk about is the time complexity of this algorithm, which is actually big O of log n. And the reason for this is that anytime you're doing a search, you essentially eliminate half of the array. So in this case, we eliminated this part of the array and focused on this other half of the array. So on every iteration, the array is actually being reduced into half of its original size, or the search interval is being reduced into half of its original size. So we have a very good time complexity, which is big O of log n. So remember that. So guys, we have come to the end of the video. I hope you enjoyed it and you have actually learned something. So if you are new here, make sure to subscribe, like, and also comment on some of the algorithms or some of the JavaScript concepts that you want me to talk about. And I'll see you in the next one.